Thank you, Kathy. So yes, as Kathy introduced, today I'm going to be speaking to you about our project investigating the effects of renin-angiotensin system drugs on COVID-19 outcomes. This is not work that I've been doing alone, so I'd like to say thank you to all of these people who have been involved from the protocol writing stage through phenotype development, code review, and now replicating this analysis in Scotland and Wales. So thank you to all of these people. So I wanted to start with some background for this project. Both angiotensin converting enzyme inhibitors and angiotensin II receptor blockers are drug classes used for the treatment of hypertension, and they increase the expression of the protein ACE2, and we refer to them collectively as renin-angiotensin system drugs. These drugs are relevant in the pandemic because ACE2 is also the receptor for SARS-CoV-2 binding and entry into the cells. And this means that we might expect these drugs to have implications for COVID-19 and particularly the severity of outcomes that people might experience. Therefore, in this study, we've set out to investigate the effect of renin-angiotensin system drugs compared with other antihypertensives on 6 COVID-19 outcomes that I've listed on the slide here. And the results that I'm going to show today relate to 3 of these outcomes, namely infection, hospitalization, and death. Naturally, when we are studying this type of question, we have concerns about particularly confounding between the exposure and the outcome. So what makes this protocol unique is that we've opted to implement an instrumental variable analysis. So for those of you less familiar with instrumental variable analysis, this is a causal inference method that uses the relationship of the exposure and the outcome with a third variable known as the instrument to estimate the effect of the exposure and the outcome that should not be subject to confounding of that relationship. And to be a valid instrument, an instrument must satisfy 3 assumptions that I've listed at the bottom of this slide. For this particular study, we have opted to use practice preference as the instrument. Typically, when using electronic health records, we'd use physician's prescribing preference, but we don't have details on specific GPs in the NHS digital trusted research environment at the moment, so we're using practice preference. And practice preference is proxied by looking at the proportion of drugs that were renin-angiotensin system drugs as opposed to other antihypertensives prescribed in the months prior to the start of the pandemic, which we've defined as the 1st of January 2020. So as my last slide suggests, instrumental variable analysis was one analysis that we implemented under this protocol, and we selected our instrument empirically for that analysis using F statistics, which are a measure of instrument strength, and varying the amount of data that we used to define that instrument to find what was the optimal amount of data to use. The instrumental variable analysis doesn't need to be adjusted for confounders of the exposure outcome relationship, but it does need to be adjusted for things that might affect the instrument exposure relationship. And so we included average practice age and practice size as covariates in this analysis. The best approach we feel to answering the question is to use multiple methods and look for consistency across them. So as well as the instrumental variable analysis, we also employed several multivariable logistic regression analyses. These included the no adjustment, basic adjustment, and full adjustment for a range of covariates from body mass index to index of multiple deprivation, consultation rate, use of various drugs. And then we also implemented an analysis that used a propensity score, and that propensity score was derived using a backwards selection procedure on that full list of covariates with a p-value threshold of 0.2. And as I alluded to, it's the results across all of these analyses that we will present and use to increase our confidence in our findings. So this particular study hinges on this 1st of January 2020 date where our follow-up for the study begins. And post the 1st of January 2020, we have our period of follow-up. And at the moment, based on the data extract I'm using, that finishes on the 31st of December 2020. In the 6 months immediately prior to the start of 2020, that's when we define our exposure. And we've defined exposure either as 3 prescriptions in the 6 months before 2020 or 2 prescriptions in the last 3 months before 2020. Then if we look back beyond the 1st of July 2019, that's where we're defining our covariates and our instruments for this analysis. So as well as this kind of structure that we have for our study, there's also the standard inclusion and exclusion criteria that you'll be familiar with from other work. So this analysis is restricted to adults, so everyone was required to be over the age of 18 on the 1st of January 2020. We also, at the moment, have a restriction on the main analysis for people to have a diagnosis of hypertension. And this is about making the treatment group and the comparator group as similar as possible. So we want them to be ideally receiving these drugs for the same indication. This question lends itself to a couple of different comparisons because there's 2 drug classes here, and also it's not uncommon for people to be prescribed renin-angiotensin system drugs with other antihypertensives. And the protocol includes 8 comparisons, which I've listed on the slide today. But for the purposes of the presentation, I'm going to focus on the main results, which are the renin-angiotensin system drugs with other antihypertensives versus other antihypertensive drugs as the control. So I won't make you wait any longer. Here are our results from the logistic regression analysis. And you can see overall, the picture is that these drugs protect against COVID-19 outcomes, with the protection increasing seemingly as the COVID outcome gets more severe. So if we look at infection, we've got an odds ratio of 0.87, but by the time we get down to COVID-19 death, we've got an odds ratio of 0.72. The instrumental variable analysis results show a similar picture. So they suggest that the renin-angiotensin system drugs protect against COVID-19 outcomes. But it's important to note that these results are on a different scale. They're on the risk difference, not the odds ratio scale. But in terms of the overall picture, we're seeing very consistent results across the 2 analyses. So our work, like all work, has limitations, and we've tried extensively to control for confounding, but we can't rule out the possibility of uncontrolled confounding in these analyses. Another concern is that the intention to treat approach that we've used does not account for changes to treatment. So your treatment's kind of locked in that 6-month period before the before the 1st of January 2020. We are also aware that there's a hierarchy of antihypertensive treatments, and this means that some drugs are likely to be more common among high-risk patients, and those patients may also be at increased risk of COVID-19 outcomes, and that could distort the relationships we observe. Finally, any practice level differences that occur in the data are potentially impacting our instrumental variable analysis, because that's using a practice level instrument. So these practice level differences can have an impact there. So this work isn't quite complete. There's a bit more that I need to do to define the different outcomes for ICU admission and ventilation. And there's further work to be done in terms of the sensitivity analyses and falsifying the instrument assumptions to really drill down to our results a bit more. But based on the preliminary results that I've been able to share with you today, it suggests that renin-angiotensin system drugs are likely to be protective for the COVID-19 outcomes that we've looked at so far. Thank you very much for listening, and time allowing, I'll be happy to take any questions that you have. Thank you.